Alright guys, a lot of what we're going to cover in this video you would have learned not only last year in Algebra 2 when we talked about trigonometry, but probably in geometry as well. So what I want to do is start by talking about an angle. And you guys know what an angle looks like, but mathematically speaking, that's when two rays share the same endpoint. And we call that endpoint the vertex. Okay, so we'll just draw one really quick. There's a ray, there's a ray, there's the vertex. You've got yourself an angle. Now, the angle that I just drew is not in standard position. We usually like angles to be in standard position, especially when we talk about concepts in trigonometry, which we will be doing. So standard position is when the initial side of the angle is on the x-axis and the vertex is at the origin. So just real quick to show you what I mean by that, this is when we start putting angles in the coordinate plane. So look at the x-axis there. The first ray of our angle is going to lie right on that part of the x-axis, and vertex is at the origin, and then wherever, how big the angle is, that really depends on what you do next, but something like that, draw a little arrow there that shows how the angle is moving, would be an angle in standard position. Now, there are lots and lots of ways to measure angles. The one that we are most familiar with is degrees. That you've worked with angles and degrees since elementary school. When an angle moves clockwise, okay, so in the direction that a clock would go. So if I look back at this picture, if it goes around this way, that actually gives us a negative degree measure. If we go counterclockwise, which is actually what we're most familiar with when we talk about angles, so we go opposite of a clock, that's when we get positive degree measures. So you know all about measuring angles with protractors and whatnot in degrees, so people are usually pretty familiar with degrees. Revolutions, a little less familiar, but it usually is pretty intuitive. Revolutions measures the number of complete turns an angle makes. Now, we can measure these in fractions, so it doesn't have to make a complete turn around the coordinate plane to be measured in a revolution, but that's what a revolution is measuring. I think that name revolution makes sense. When you think about a revolution, you think about like going around in a circle. And then radians bases the measure of an angle on the arc length it creates. And we'll actually be talking about that more in class, but you guys should be somewhat familiar with the term radians as well. So I have a couple pictures here, and they're going to help us achieve our goal. Our goal is to convert degrees to revolutions and vice versa. So I have a little angle here. This drawing, it's trying to show you that you start here and we go all the way around, full circle. Well, we know that that's 360 degrees, but we just made one revolution. So an angle measure of 360 degrees, that's the same as one revolution. That's going to be important in a second. But I got another one here. We're showing that we start right here and we go a half turn. So that's 180 degrees. Well, that would be half of a revolution. Now notice that revolutions, you usually have to say either counterclockwise or clockwise depending on the direction. Revolutions are never negative. In fact, you might want to make a little note here. They are never negative. You would just say clockwise or counterclockwise. All right, if we do a quarter turn right here, this is 90 degrees. That's a quarter of a revolution. And again, that was going counterclockwise. Okay, so the little key fact that you want to recognize here is that 360 degrees equals 1 revolution. That's going to act as like a little conversion factor for us. So 45 degrees, I want to convert that to revolutions. So I know that 45 degrees, okay, I want to convert that to a revolution. So here's how I think of it, and this is going to bring in some chemistry for you guys. I want to end up with revolutions on the top. I want the degree measures to cancel. So I know that in 1 revolution there are 360 degrees. Having a degree on the top and a degree on the bottom, the degrees would cancel. I'm left with revolutions. That's 45 out of 360, which is going to reduce to, oh goodness, 1/8. Okay, so that would be revolutions counterclockwise. Negative 240. I'm going to disregard the disregard the negative for a second. Again, 240 times 1 revolution over 360. That's going to be 240 over 360 revolutions. I know it would first reduce to 24 out of 36. Both of those are divisible by at least 6, so we would reduce to 4 out of 6, which reduces to 2/3. Now, this time I'm going to say revolutions clockwise. Alright, and the reason being is because this was a negative measure, so that would be going clockwise. 450 degrees. Before I even begin, I'm going to expect this to be more than 1 revolution, because 450 degrees is past 360. Multiply that by 1 revolution over 360 degrees. We're going to get 450 over 360 revolutions, because degrees would cancel. We get to drop the zeros. Both of those are at least divisible by 9, so we would have 5 over 4. 5/4 of a revolution counterclockwise. And yes, you do need to say counterclockwise or clockwise or counterclockwise. You need that part. Alright, let's look at the back page. Here we are going in the opposite direction. I want to take these revolutions and convert them to degrees. So 5/6 of a revolution. Now I'm going to multiply that by something. I want degrees to be on the top, revolutions to be on the bottom, because I want to get the revolutions part to cancel. I know there are 360 degrees in 1 revolution. Now, when I multiply these, I could do 5 times 360, but to me, that seems like a bit much. So I'm going to do a little cross-canceling. 6 goes into 6 one time, 6 goes into 360, 60 times, and then 60 times 5. That's a little bit easier to handle. That's going to be 300. And since we were going counterclockwise, that's going to be a positive degree measure. 3/10 of a revolution clockwise. Set up my little conversion factor here. So again, I'm going to do a little cross canceling. I think that that will make this a little easier. 10 goes into 10 one time, goes into 360 36 times. And then 36 times 3 would be, I think, 118. Hold on. 36 times 3. Oops, sorry, 108. 108 degrees. However, this said clockwise, so this has got to be negative. 4/3 of a revolution, right off the bat, I know this is going to be more than 360 degrees because it's more than one revolution. Again, make your life a little easier. If you can, cross cancel, and we can here. 3 goes into 3 one time, goes into 360 120 times. 120 times 4 is 480 degrees. That was counterclockwise, so that's going to stay positive. Okay, so hopefully you kind of remember doing some of this stuff in Algebra 2, and this was just a little refresher for you, but we will pick back up with some more discussion about radians in class.